So we have lots of rectangles here. Okay, so we're doing this and doing the distributive property. We're going to be doing it by finding area. So when you think of the area of a rectangle, go back in your brain. What is the formula for the area of a rectangle? Length times width. Length times width, right? Length is usually the longer side times width being the shorter side. All right. Okay, so let's take a look at these. Number one, I have a rectangle with length 5 and width of 4. What is the area of that rectangle? 20. And how would we label this usually? 20 what? Ballerinas? There's nothing written, so in this case it would be units squared. Yes, because area, you're trying to figure out how many total 1 by 1 unit squares would be in that rectangle. All right, number 2. I have a length of m and a width of 7. What is the area of that rectangle? Length, width. What did you tell me I need to do to find area? Multiply them together. So what do I get for the area? 7m. Oh, you're gonna mess me up, man. Sitting back there. So Jamani's not here. Okay. All right. Jump now to number 5. Or you can do 3, 4 on your own. But let's look at number 5. So 5, they're showing over to the side, this has a length of 4. This has a width of x. And then we have this other rectangle near it, which also has a width of 3. Okay, so what is the area of the first rectangle? Four x, right? Because you're multiplying length times width. So 4 times x is 4x. What about the second rectangle? You put your hood down, Rodney, and the headphones, take off the ears. What about the second rectangle? It has, what is its length? It's not written right beside it, but what is it? Yeah, it's still 4, right? So this is 4, and with a width of 3 gives me an area of 12. So this is, if I would push them together, 4x plus that 12. 4x plus 12. There he is. All right. Questions on 5? Thank you. I give you a book? Yeah, you can sit there. So number 11. Now we have a larger rectangle made up of 2 smaller rectangles. Okay, so let's find the area of each individual rectangle first. So what's the area of the rectangle in blue? 5x. 5 times x, which is 5x. We're on page 70. Yes, that's yours to keep. And what about this rectangle here in green? What is that area? 35 by taking 5 times 7. So what is the total area for the larger rectangle then? Say it again.
35 plus 5x.
Right, and mathematically we would usually put anything with a variable first because that is to a first degree, like 5x to the first. So we would say altogether that is 5x plus 35, right? Okay, you're like, yeah, I can do this. Yes, this makes sense. All right, number 12. What is the area of this first rectangle? X squared, x times x. And that is not 2x, it is x to the first times x to the first. Remember, you add the exponents, which is x squared. What's the area of the second? 12x. Put it all together, we get usually the one with the higher degree. So x squared plus 12x. Okay? Questions on those first examples? So we did 1, 2, 5, 11, and 12 out of your workbook. All right, so distributive property. Go ahead and 14, if you work that out, what would that be using distributive property, putting it all together? You are distributing the 4, and always make sure you are multiplying. So 4 times x is 4x plus 4 times 7 is 28. All right, what about number, I guess we'll do 16. 16 says negative 2 times quantity x plus 4. What would that be using distributive property? Okay, come on, not all at once. Negative 2x minus, because you've got the negative times the positive, which gives you minus 8. Okay. Ooh, I didn't see 12. I didn't see the bottom area. So let's go back. Take a look at 11. We did the area as a sum, which you guys are like, why is she asking when it's right there? I didn't notice that. Where did they get this 5 times x plus 7? Where did this come from? Okay, so this is the length and width of the largest rectangle. Okay, when you're doing area as a product, you're looking at the large rectangle overall. So 5, you could say, is the width, and then you have this much was x, this much is 7, so the total would be x plus 7. And you have to keep that together because that's the entire length of the longest side. Does that make sense? It's okay to say no. Just say no. All right, let's take a look at 12 because I jumped the shark, as they say, maybe. So area as a product. I'm looking at this entire large rectangle, okay? The large rectangle. And we want it as a product. Product means what? When I say product in math, what does that mean? Multiplication, and specifically it's the answer, right, to your multiplication problem. If I'm looking at the large rectangle, how do I find area of that large rectangle? I have to multiply length times width, right? What is the length or longer side? What is the length or my longer side in number 12? Just 12? Of the large rectangle. So I'm looking at this rectangle right here. Yeah, this much is x, this much is 12, so the entire length would be x plus 12, right? And what is the width then of that large rectangle? X, right here. X. Now, I'm going to put it out in front. The length and the width, I say length is longer, but not always. So this is showing the area as a product where you are multiplying. Okay? And then the area as a sum happens when you've already found the area of the two smaller rectangles. And you're putting them together. So here, I'll make this a little wider. Here I have x squared. That's the sum of the first rectangle plus 12x. And when you look at these, hopefully you notice, yeah, if I just distribute this x from the multiplying one, from the area as a product, that gives me the area as the sum. If you remember from yesterday when we were doing that card sorting activity, you had one table that usually went with sometimes two different expressions. And if you remember, they were probably similar to 2 times x plus 3. So that would be your area as a product. Or they could be, after you distribute, 2x plus 6. Those were the two that likely went with that table. Okay? Questions on that? All right. So 15, somebody give me that distributive property answer really quick. What would that be? 7x minus 21. And what about 17? X squared plus 9x. Remember, when you multiply x times x, that is x squared. You can put it right in there. Thank you. All right. Any questions on that? Okay, let's jump now to page 71. Everybody's favorite when it comes to factoring. Ooh. Right? Factoring. If you think of factoring as reverse distributive property, that might be an easier way to think of it. Okay? So here, let's look at number 2, if I can, there we go. We have an area of 5x for this rectangle. We have an area of 20. We know the common factor, greatest common factor of both of them is 5. So if you factor out that 5, what will I get? X for the top one, and what about for the second rectangle? Right, because you're taking 20 divided by this, which gives me 4. So let's write these first as a product. If I were to, let me see, I didn't bring my cheat sheet over here. Well, let's see. I'm trying to think what we were probably looking for here. Probably if we're factoring, maybe the fact that we're factoring out a 5 from the 5x and 20, which leaves me with x plus 4. So when you are factoring, you are doing the opposite of distributive. So this would be the product by factoring it out. The sum we already have. Let me think. What else should I be looking for here? 5x 35. I guess, yeah. So then the sum which we already have, would be the 5x plus 20. Okay? Does that make sense? Okay. Let's look at number 3. So they give us the sum, okay? So let's put that on the bottom. That is 6x plus 48. That is the area of the entire larger rectangle, okay? Now this time they don't tell me what I'm factoring out, although you might be able to figure it out. They do tell me that this amount here is 8, okay? So if you take 48 divided by 8, what must be the greatest common factor? 6. So this is going to be 6 over here. So we're factoring out the 6, and 6 divided by 6, or 6x divided by 6, leaves me with x up here. This amount is x, and this amount is 8, so I will add those together. So that's your product. Okay? Are you with me? Okay. Questions on that? All right. Number 5 says 5x plus 35. That is your sum. Okay? So what is the area of this first rectangle? 5x. It's this amount right here, right? What's the area of the second rectangle? 35. Okay. And then they show they have factored out the 5. The 5 is consistent or the same for both of them. That 5 is going to be factored out over here. So it's reverse distributive property. 5x divided by 5 is x. That's going to go up here. And 35 divided by 5 is, 7. Close. So up here, if this is length x and this is length 7, the entire length total is going to be x plus 7. And for some of you, I know you're thinking, wow, this is not really that hard. And maybe it's not, but when you do it on your own, it's a little bit different. Isn't that just like homework? You know, oh, we did 1 plus 1 is 2 in class, and then we had 4 apples eaten by 5 aliens gives me a green roof. How many rainbows are in the United States? You know, it's like, what? No. All right, so number 8. Number 8, going down below. 7x minus 21. How is that going to fit within my larger rectangle? So the first rectangle would have an area of how much? 7x. The second rectangle would have an area of negative 21. Now, what is a common factor for both of those? So reverse distributive property. What's going to go right here? That's reverse distributive property. It's a factor of 7x and a factor of negative 21. 7. So 7x divided by 7 gives me x up on top. And negative 21 divided by 7 gives me negative 3. Now this is where I think it gets a little wonky. Because you're saying, okay, this has a length of x, this has a length of negative 3, so it's stretching it a little bit for area. So, but up here we had that common factor of 7, And up on top, this length is x minus 3. Okay? So yeah, I'm not sure how we get that is minus 3, but we'll go with it for now. All right, so looking at these last two, 4x minus 16, that is the area of the large rectangle. If I want to find, this is the area of your large rectangle. If I want to find the, quote, sum of both of the smaller rectangles, that's what I would get, okay? Now I want to find the product. So I'm going to do that reverse distributive property. What is the greatest common factor of both of those terms? 4. So you factor out the 4, and for my kiddos and my classes, I will actually write divided by 4 there to help them out. So 4 divided by 4 simplifies. I'm left with x here, and negative 16 divided by 4 is negative 4. So this would be right here your common side, and this would be kind of your length on top. Okay. And the last one, 9x minus 81, that's your sum, I guess you could say plus a negative, sum of your two areas. What's my common factor there? 9, because both of them are divisible by 9, so that's your common side. 9 divided by 9 simplifies, you're left with x, and negative 81 divided by 9 is negative 9. Okay? Any questions on these? Okay, let's go one more page, then page 72. Now we're going to be drawing a little bit. We're going to prove whether these expressions are equivalent or not. And I know you already know, but we're going to prove it. We are going to prove it by drawing them. Yes, we are, Cameron. Yes, we are. All right, are the expressions equivalent? Sketch and simplify to prove. If the two expressions are not equal, write the correct equivalence. Okay, so first up, we have 3 times quantity x plus 3. Okay, this is the product. This is the product one, right? So I need to show this as width times length. Width times length. Okay, I don't like how that's way over there. So if that is my common width, I'm going to put the 3 over here. It's like I'm factoring it out. Okay. So this is my larger rectangle right here. And if that is my common width, what goes on top? So this is my width. This right here is going to be my length. And this has a length of x plus 3. Okay? So width and length. Now, is that the same as 3x plus 6? Well, we need to draw a picture. Okay? So, I'm going to do this down here. Okay? This is the sum of two smaller rectangles. All right? So, what is the sum of my first rectangle? What's the area of my first rectangle? What is the area of my first rectangle? 3x maybe? Right? 3x. That's the area of my first one. Okay. Something like this. And we're going to say that that area here is 3x. And over here we have the area of my second rectangle, which is 6. So putting it together, that's my 3x plus 6. So over here, if I do that, what do I get for the area of my first rectangle? 3x. And what do I get for the area of my second over here? 9. So are these equivalent? No. So how should I rewrite that second one? So 3 times x plus 3, write the correct equivalence, is equal to, not this, but it's equal to 3x plus 9. So this is the correct answer. Does that make sense to people? Kind of. Okay. Are we ready for the next one? But wait, there's more. All right, next problem, as you are seeing it, says 6 times y plus 1 and 6y plus 6. All right, so this is my product of one large rectangle. So it has a width of 6 and it has a longer side of y plus 1. Okay, y plus 1. And mine is not very good to scale. Okay, so is that the same? Maybe I'll just do it over here. Is that the same as 6y plus 6? I mean, we already know the answer. So what the area of my first rectangle would be how much? Area of my first rectangle in this right here? 6y. And the area of my second rectangle? 6. 6 times y gives me 6y. 6 times 1 gives me 6. So yes, these are equivalent. Yes, equivalent. And again, I know you may already know that using distributive property, we're just trying to show it through areas. Okay? All right, last one. Distributive property. Are the expressions equivalent? Sketch and simplify to prove. So again, this is my one large rectangle, which has a width of x, and it has a length of x plus 4. So here's my large rectangle. Is that the same as the sum of the two smaller rectangles? So my area of the smaller or the first rectangle is x squared. And what is the area? Supposedly it is 4. Okay. Is that going to work? Are those equivalent? No, because this should have been x times 4 to give 4x. So x squared plus 4x is what it should have been. Okay, so over here, x times x plus 4 should have been x squared plus 4x down here. So this is not correct, and they originally were not equivalent. All right? Questions on that? Okay. That is all the notes that I have for today. You can now work on the last homework of distributive property. Remember, we have a test this Friday. I think all of you do have the review, right? We picked that up yesterday. Did everybody get a copy? Did anybody lose their copy yet? Okay, I will get you another one. Has anybody, you too? Oh, yours I have, because I think you left it here. Yes, so I still have that. Has anybody started on it or looked at it just a little bit? It's okay if you haven't. Okay. So tomorrow, make sure you bring that. Maybe start looking at it a little bit more. I'm gonna give you time in class to work on that for the most part tomorrow. And then Thursday will be all questions from that. I also will have the answers and the work to it. And yes, you can turn it in 4 points. Okay. I do want to make sure you understand how to do all of the things that are expected on the review, which will also be on the test. Okay. Arturo, I'm not expecting you to take it, but the homeworks are all online on Canvas. So the first one was just a getting to know you kind of thing. What makes you happy? You upload a picture, give me a short description about what that is. The next one is Math Magic. That might be a little tough, and it was a little tough for some of you. I did start grading it finally early this morning. I'm only about halfway through. So if you don't have a grade yet, it'll be coming later today. Huh? Trying to think. What was 1, 2 about? I want you to try them. Yes, try them. Yeah. This one, 1, 3, I think you'll be fine with. 1, 2 happens to be, I think, noticing things by way of patterns. So I think that would be good. 1, 1 is the Math Magic. You probably can do that one, but it might be a little weird to you. Okay. So again, Friday, big first test. So please start looking at the review. Be ready with individual questions maybe tomorrow. If you know you're like, I don't really know this, be ready with some of those, but we will go over any and all questions. We might not be able to get through all of them on Thursday though. Okay, so make sure you are ready with questions that you have or need answered.